Okay, so this is 4.2b, and we're talking about the water holding capacity of different types of soil. So, we have sand would take, if time was 0, we have sand would take an hour, silt 100 days, and clay 100 years to go through. So that's just remember that, which one the water passes much more through the larger particles because there's spaces in between them, right? So the clay is smaller, they're compact in the clay, so the water can't get through. It just sort of sits there, but with the sand, it just falls through. Okay. Oops. What did I do? I'm always doing that. Okay, so measuring soil composition, and here I go, traveling again. Whoops, I'm going to go over here. Sorry. Okay, measuring soil composition. Soil composition can be determined by percentages, and we use something called a soil triangle. You don't need to memorize all the soil combinations at all, but you just need to know how to use this triangle for the exam and, for trying to figure out soil. So we're going to be doing an experiment, a lab experiment. You're going to be doing it at home. You're going to be using 3 jars that you can find at home, like pasta sauce jars or water. Not water. Water bottles don't really work. Well, you need something with a wide mouth. Ball jars, anything like that with a lid. And you're going to be collecting 3 different samples from 3 different places around your house. And you're going to, I'll tell you more about it, but you're going to be using this triangle to try to figure out where your soil fits within these percentages. So knowing the percentage of sand, silt, and clay can determine the kind of soil it is. So we're going to get a little bit more into it in the next slide, so I'm not going to talk about it here. Okay, using the soil triangle. So here it is. This is the soil triangle. So if we have, let's say, 35% sand, 30% clay, and 35% silt. Let's look at this. So we have sand across the bottom, clay across this side, and silt over here. And we're talking about the separates. So this is once the clay is separated, right? So if you measured your sample and you see that you have 35% sand, 30 clay, and 35 silt, well, those are kind of equal amounts. But let's see what happens. So we have our sand and our clay and our silt. So we have 30% clay. See clay, 30%. We have silt is 35%. We draw a line. And then we have the sand is 35. We have 35 and we draw it. And right where the intersection of all these is the type of soil that we have. So we have loam, and it's really a clay loam. So that's how you do it. All right. So yeah, that's it. So soil, we test soil in 3 different categories. We can do chemical tests, physical tests, and biological tests on soil. It's a lot of fun. We're not going to do all of these in class because of our remote situation. But what we test for with chemicals is nitrogen, phosphorus, potassium, and pH. So we call that NPK and then the pH. And there's different ways to test it. The test strips that we have in the school right now are these little test strips, and you dip them in something and then they turn colors. But there's also these pH test kits where you actually put water in them. The pH when you put distilled water, and then you put a soil sample, and then you let it process for like an hour, and then you read the colors, which is kind of cool. So you can tell what the phosphorus levels is by looking at this. We're all the way down here depleted, and then over here, we have probably also a deficient. It's hard to tell with these pictures, but anyway, so you can see how you would use those tests. That's the chemical tests. Physical tests determine the amount of percolation and infiltration. So percolation is the movement of water into the ground, and infiltration is the movement of ions or chemicals through the percolation. Here's a little bit more about our lab that we're going to be doing. You're going to be collecting 3 samples, and you're going to label them, and then we're going to let them sit. We're going to shake them up with some water in it, and we're going to let them sit, and then we're going to decide how you're going to measure them, and we're going to decide how what kind of soil it is. So that's going to be